we have the same denominators. We're gonna keep that same denominator, which is 3. And now we add the numerator. So 1 plus 4 is 5.
Wow.
And that's it.
Wow.
The thing is this. Sometimes you have the answer, try to simplify, which is to reduce if it's possible. So you find that common factor from the numerator and the denominator, which is going to be cancelled, and you get your fraction in simplest form, in lowest form. So here, the 5/3, you cannot do anything about it. So that will be that answer. 5/3. But 2/7 plus 3/5. Because we don't have that same denominator, we need to work on the fraction to get the same denominator. Okay, and for that, we'll try to find something called lowest common multiple or lowest common denominator. So LCM, so lowest common multiple. So it's gonna be that lowest number, lowest value, which is the same for this first fraction and the second fraction. So for that, from 7, you'll try to find multiples you have. Same thing for 5, multiples you have. And you'll see that, at some point, both the multiples from 7 and multiples from 5 will have the same multiples. It could be 1 or more than 1, but we are looking for the lowest. That lowest we're gonna use. Okay, so we have a different method, to find these multiples. But I will use, the short method. That short method is what? Having 7 and having 5. You see? Because they don't have that same denominator and we want to figure out that same denominator, we're going to use a multiplication method, which is what? We're going to multiply the numerator and the denominator of each fraction by a number, by that same number. Or we know that doing that multiplication from the first fraction and the second fraction will get the same denominator. So like here, if I multiply the first number by 5 and then multiply this denominator by the same number, 5, I will end with what? 10 over 35. Okay. On the other side, because I'm looking for that same denominator, I will not multiply the second fraction by 5. If I do that, I'm going to have 25, which is not helpful. I'm looking for that same denominator. So I will switch. So here I have a 3 and a 5, but I will multiply 3 by 7, 5 by 7. And let's do it here so I can keep the answer here. So we have 21 over 37. 35. Thank you. So I want to mention something. Multiplication table is simple, but people don't like to learn, especially for high school students. Why? They don't like repetition. They don't want to practice. It's not just one time you get that multiplication table down. You have to practice. You have to repeat it. Because they don't like repetition, they don't want to do it. But it's very important. Yeah, we know that they could use a calculator to do this, but sometimes, calculator, use your time because the exam or the test is timing. So you have to go fast. That's the reason some students don't finish their work before the end of the
question.
So,
Is
yes.
it faster to use a calculator while taking the test, or just to use your brain?
Yeah, if you have a simple multiplication like this, I think it's faster to use your mind instead of a calculator. Yeah, because using calculator, you think like it's simple, yes, but pressing all these keys from the calculator, you are losing some few seconds, and little by little you add all this together, it's gonna be more.
But you know, there's some calculators that you could work fractions on them, and they will give you
the answer right away. Yeah, it's also like that. But trust me, for college, there are some classes you will take with no calculator, especially from pre-calculus. Pre-calculus, they don't allow you to use a
You can't even use calculator. No, pre-calculus. It doesn't work.
No calculator. So if you are addicted with this calculator and now you are taking pre-calculus, trust me, you're gonna have a lot of trouble. That's why you have to be prepared. So be prepared. If they say to use a calculator, no problem, you can use it. Be prepared if they say, okay, do not use a calculator. That's why you have to be that open mind.
So when they tell you to use calculator, it's like a bonus.
Yes, bonus, and use it. If they say no calculator, no trouble. You know that you can do it without calculator. You see. Okay. So we have a 10 over 35 plus 21 over 35, and now it seems like the example we did over there. We just keep that same denominator 35, and we work on numerators, the top numbers. 10 because it's addition plus 21, and that gives you 31 over 35, and there is nothing to do with this. Okay. One more example because I want to mention something which is very important. Suppose you have 2 over 3 plus 2 over 5. That is another trouble. I say trouble because students, maybe they learn, okay, if you have the two fractions you want to add and they have the same denominator, okay, you just work on the top. Now the thing switch. They have the same numerator.
I got a question for you, right, Professor? Yeah. So when you give out question, do you see the question as a problem or trouble or like a challenge or as a question, or how do you see the question when you doing math? Do you see it as a challenge or like a problem or trouble or question, or how do you see questions?
Okay.
Questions.
Yeah. The question is like a challenge. Why I say this is like a challenge? Because based on my experience, you see how people, what students especially.
Or do you see like a puzzle that you have to, you're trying to figure it out, or you're trying to find out, okay, where does this lead to?
Okay. Let's be specific. Suppose I'm grading 30 students exam or test. Okay, for a question. People, maybe from 30, maybe 15 will get right or less than 15, and the rest, will get wrong. And from the wrong answers, you will see different wrong answers. That's the way I pick my next question. Because when I say, oh, that's the way this student answered the question, which is wrong, I saw the mistake. So from one question, you can see like 10 or maybe more than mistakes. So my next question, I will use that mistake to teach, and I will use that mistake to figure out, the way people have to solve, the question.
Okay.
You see?
Okay.
So I see something in the previous video. You have to learn from your mistake.
Okay.
Okay, you learn from your own mistake, but it's also important to learn from people's mistakes.
Yeah.
Because you cannot just be like, okay, I'm gonna learn from mistake and then you have to do all mistakes. No. You do mistake, you learn from your mistake, but you learn from other mistakes. So that's why I just show students the different kind of mistake people can do. So if you learn this, that helps to avoid those kind of mistakes in the next test or question of this.
And I got a question. One more question. Say you give out a question, right? And the student get the answer right.
Yeah.
Right?
Yeah.
But it didn't follow the like a normal steps.
Yeah.
Right?
Yeah.
Can you take your time to trying to understand the step that the student follows to see if it's like accepted?
Yeah, that's the good part of math. You know, you have a different methods to solve the question, but what is very important is to explain your method.
Oh, okay, that's what.
So if you get the right answer using different methods, but you explain your method, you get full credit. Yeah. So it's not like, okay, you have to follow your professor method. Maybe my method is complicated for you,
okay,
but you learn a different method which is simple. That's just fine. Use it.
Do you see that when you grade papers? Like, oh, share you went a different route.
Yes.
I think I like that.
Yes, yes. And this is again a good part of teaching. Because as a teacher or professor, you learn from your students. That's why I like a class where you see your students asking many questions or they participate. You know, that's the way you learn. And again, you give a question, you teach a method in class, and you see that, okay, there are some students, or you see a student use a different method. Okay, during the correction, I will point out, you know that, okay, sometimes you can use this kind of method because there are some students use this, and maybe that will be helpful for other students. If it's helpful, that's fine. But anyway, you have to show the student different method to approach the question, which is again very important because we learn, you know, in different ways. So it's not like, okay, I'm good in this method and all students will be good in that same method. No, it's different. You see, but it's very important to have that open mind, you know, to learn from other people. Even if you're gonna use that method, but it's very important to learn that method. Okay, so the way I point out this kind of question, because having the same numerator, students could put wrong answer like this. Trust me, wrong answer like this, 2/8. And we say, oh, Professor, you see that in class that if you have two fractions with the same denominator, okay, you just keep that same denominator and you work with the numerator. Now, the question is, 2 on top. Do you think 2 on top are the denominators? That's the numerator. Yeah. So, you see? So, denominators means numbers in the bottom of the fraction. And the numerators, numbers on top of the fraction. And the student always mess up with these two key terms. Numerator, denominator. It's like a less than and a greater than. Trust me. Students sometimes they call it's less than as it's greater than, or it's greater than they call it as it's less than. Okay, so we're gonna come back to this. So this is a wrong answer because it cannot be 2/8. Again, we need to find that common denominator. So from 3 and 5. So the LCM, which is gonna be another video, we can work on how to find LCM because it have to be something we explain in detail. But for now, I can multiply this by 5, because doing that, I have that similar, fraction. So we get 10 over 15 plus 6 over 15. And yes, in this situation,
so it's like you're switching the denominator.
Yeah, I
You switch the one on the left to the right and
yes,
to multiply.
yes,
Yeah.
But we'll see if you have a large number. Yeah, it's gonna be hard for you to use that same method. That's why I say in another video we'll come back to how to find LCM in detail. Yeah, in detail. Okay, so 10 plus 6 is 16, and 15 will be that common denominator, and you have 16